Good morning, Marauders. Welcome, welcome, welcome. I'm going to do a recorded lesson here for you. And hopefully we're back like this. Woo! Anyway, we're doing 4.1. We're starting trigonometry, which is a big unit. So I'm going to give you the basics of how to do it. And we're going to do part of it today and part of it tomorrow. We'll spend 2 days on this section and then 2 days on section 4.2. This is our last week of the semester. It's our unit 10. I'll just kind of show you where we're at. So here's unit 10. So we'll click on this and I'll run through all the basics here. And here we go, unit 10, week overview. And we'll cover all this stuff in class and all these little announcements you can read on your own on Canvas. And here's an important trig sheet. I put this up here and here it is in yellow, all this good stuff. But anyway, let's get into how do we do Monday's lesson. We'll cover all that stuff in class. But let me show you how do we do 4.1. Okay, and I put 2 days. And so let's see how this works. So let me switch to my camera here. Okay, so this is chapter 4, and you're definitely going to want to read the book to see how to do all this stuff. So I'll try to explain all this stuff, how to do it. It's going to tell you about angles. There's a bunch of vocabulary. So let me run through all this vocabulary and just try to rephrase it and what all this stuff is that you're seeing. Okay, so here's some paper. Let me get this so you can see it. Okay, so you know about angles. We're going to talk a little bit about angles, which you can't see. There it is, angles. And this is kind of a neat little thing. Here's an angle. So an angle, you've probably seen this, it's how far apart these two rays are. As they get wider and wider, we say it's a bigger and bigger angle. So you've probably heard here's 0. As you see, it gets bigger, 10, 20, 30, 40, 50, 60, 70, 80, 90. That's why people say 90 is a corner. And of course, we could keep going though, right? We could go to 100 degrees, 110, 120, and keep going. When you get to 180, you've gone all the way in the opposite direction. That's why when somebody makes a U-turn or flips around the skateboard, they said they do a 180. And you could keep going, a 190, a 200, a 210. We're going to deal with all 360 degrees. 360 is all the way around. And of course, here it says 340, 350. And of course, what would be next? 360 is you've made it all the way around the circle. Okay, so 360 degrees all the way around. But one thing is you saw where I started, but in the book, we're going to do it like this. But let me just put a little bit about an angle. So we have a ray, and here's another ray. These are rays. And this first one, we call it the initial side, like initiation. So that's to begin, and this is going to be 0. And this is the terminal side. Terminal is the end. Like if you say that patient is terminal, that means that's the end. And we open up these angles, and sometimes we draw like this to try to say that I was doing something like this. And of course, this one goes backwards, unfortunately. Maybe if I went like this and did it in white, we could say we're going this way. And what you're going to find is like, where do you start? In the book, we're always going to start over here as 0, and we're always going to start pointing this way, and we're always going to go upwards. It's like backwards from a clock. We're always going to go this way, and we're going to go 10, 20, 30 until we get all the way up is 90. So we're always going to go this direction. Okay, so you just got to get used to that. And just like on graph paper, this is quadrant 1, and if you went past 90, like you went over here to 100, 110, and these are all in what we call degrees. Okay, that's just the unit they called it. And over here would be quadrant 2. So if you did 110 degrees, we're always going to start over here, and we're going to work our way over. So we're always going to start here. That's just the way we're going to do it. And this is quadrant 2. And of course, when you get over here, you're at 180 degrees. And if you kept going, well, you'd be past 180. You'd be into quadrant 3. You could get way down here like at 225. Way down here would be 270. You're 3/4 of the way. And here's quadrant 4. And here you're like at 300. And eventually you get all the way back to the beginning. So we also call this 360. Okay, all the way around. So let me show you some stuff in the book. And there's a lot more to it. So they give you some of the words I told you. And so you see pictures like this, the initial side, the terminal side, there's your vertex. And sometimes we use a little unit. This little funny little circle right here, that little circle, that's a little Greek letter. It's a circle with a line right there. It's a circle wearing a belt. We call that theta. And it's just a letter they like to use for measuring angles. Now, you don't have to use theta. Here, this looks kind of like an A. And this is a Greek letter. This little squiggly guy looks like a little fish. That's alpha. So he kind of looks like a letter A. So sometimes they call this angle alpha. And you notice he went from quadrant 1 to quadrant 2. As straight up as 90, he went more than 90, maybe 110. Okay. And here's another one. And this one I used theta. And you might say, hey, they went backwards, didn't they? Oh, yeah, they went backwards. Normally, we're going to go forward. And so if we go forward, and I lost that little screw already. I tried to use a little tool there. Okay, I'm going to grab this paper clip. Okay, so as we go forward, right, these are going to be positive angles if we go this way. But sometimes people like to go the other way. And if we happen to start going this way, we're going to call it a negative angle. Okay, we're going negative. And so that's what they tell you about positive angles and negative angles. So generally, you're going to start, whoops, let me go over here. We're going to start here and go around. Look how far they went. And go, what's that thing? Well, sometimes they want to use another letter. It kind of looks like a B, but it's kind of curvy. That's beta. So sometimes we have alpha and beta. Just like when we have X and Y, we have alpha and beta. Or we have theta. This one went 270 degrees. And of course, some other things. If you only go less than 90, we call it an acute angle. If you get all the way to 90 degrees, a corner, we say 1/4 or right angle. And if you go a little farther, they call it obtuse, which means you're not quite the 180. And of course, some people can call this a straight angle. So this is a big deal. I'm going to pause my recording. Okay, and then now here, it's such a big deal, I made this, okay? Yeah, this is my wheel, okay? And so, as you see, here I start at 0 degrees, and we go this way. Hopefully it's not backwards on the camera, but there's 30, 40. It's probably all reversed looking at this, so I'm not sure how well this is going to come out. 60, 90, and some people measure these because these are just popular. Like 30 is 1/3 the way, 45 is half the way. You've heard of a 45-degree angle, a perfect angle. And so as we go around 120, there's 180, and we keep going to 270 and all the way back to the beginning. This little ribbon is very important. We'll learn about later. And you probably said, what are these other little things? These little fractions with pi. Okay, we'll talk about that in a little moment. Okay, so let me move this out of the way. Okay, so they have some things, they give you some examples, like to draw angles. They say, draw me a 45-degree angle, but see where they always start? So I have to kind of use the white side of this, and now my numbers are all backwards. Now, if I looked at it like this, I could go, oh, 45. But where are we always starting? We're always starting over here and then going up to 45. Okay. So there's a 45, 225. So you have to think, see, 90 and another 90 is 180. So you have to get kind of used to where these are at. And on my site, I've got this yellow sheet. This is Newell's Amazing Trig Sheet. And there's a lot of rules on here. And of course, you can't remember them all. Remember them, can you? But on here, there's a nice little wheel here. And on here, you can see 0, and I kind of wrote some numbers here to help you kind of just do the most popular ones that kind of remember where you're at. Okay, so there's 225. You're in quadrant 1, 2, 3. Okay, if you forget the quadrants, it's on my amazing sheet. There's number 1 where you start, then 2, 3, and 4. Okay, here's a negative 135. So you have to think a little bit there. You have to go backwards, 90, and then a little bit more. When I think of some of these, like 135 to get it right, I think of that as 90 plus 145 is 135. So I went 90 and then perfectly diagonal, another 45. But this one was negative, wasn't it? Because we went the wrong way. Okay, and here's a 405. That's more than 360. In fact, how do I know that where that is? Here's some tricks. They're going to ask you some questions like, can you name another angles in the same spot? Like, okay, maybe I went this way, right? But what if I went forward? Instead of me going whoop, backwards, what if I decided to take the long way and went the positive? Do you know what angle that is if I went positive? Here's a little trick. Whenever you're trying to name the other angle, here's the trick. Either add or subtract 360 and you'll find the matching angle. So if it's like negative 135 and you wonder what the positive version is, just take like a calculator, which I lost my calculator. Okay, I'll use this cheap calculator. And oops, that one's not good. I could put in negative 135 and I go, what's the other angle? Just go add 360. And you go, oh, 225. 225 is the same angle. Okay, so 225 this way is the same as 135 backwards. And I'm wondering, what's another way to do 405? If you spun around 405 degrees, okay, let's try to get this to work here. Here we go. You notice you did a full 360 and a little bit more. How much more did you do? Just do this, either add or subtract 360. Since they go, ooh, that's a big number. Let's take 405 and subtract 405 and subtract 360 and go, oh, that's 45 degrees. That's right. You did a 360 plus an extra 45. That's a 405. Okay, so if you just add or subtract 360, you'll find another angle. And we call those angles with the same name coterminal. Co means together, like to cooperate. So coterminal means two angles that have the same spot. Okay, and so they kind of give you a little tip here. Whatever your angle is, and there's degrees, and K is just whatever number, and they say add, and that's a little confusing. What do they mean? Well, add 360, or maybe more than 1 360, or subtract. It's not a good explanation. So here you go. What's another way to be at 420? They go, well, that's a big number. Let's subtract 360. That's 60 degrees. That would be the same angle. And here's a negative 120. They go, that's negative. Why don't we add 360? That would be 240. And then they show you the pictures. Here's 60 degrees. Try to focus that in for you. So say you're like an ice skater, and I keep losing that little screw there. Say you spun 420, that meant you went wee all the way around and kept going a little farther until you fell down. So you see how they say go all the way around? Well, you're 60 degrees past where you started. Okay, there you go. If somebody spun this way 240, they could have spun backwards negative 120. They'd be at the same spot. We say they're coterminal. Here's a little bit more about angles. Here's a neat little, you're familiar with regular protractors. Let's see, here's one that goes to 360, but this one starts at the top and goes this way. In real life, or like we're using the Earth, we usually like to start here and go this way. But like I say, in math, we start over here, because that's like where the number line is, where the x-axis is. And then we're kind of upside down going 30, 60, 90. Okay, yeah, I know we kind of go a little opposite of reality. See, this one goes around to 360. Okay, we'll talk a little bit more about that. Okay, so what else? They also go back and do a little geometry. And all this stuff will be important later. In trig, everything you learn, each section is going to build upon it. So you don't want to get behind, because if you can't do section 4.1, you can't do 4.2. Okay, and they say find a complement. Okay, here's some words you may forgot. If you forget, they're right here. Complements are angles that add up to 90, and supplements are 180. In other words, if I put this right here, and I drew myself an angle, let me just draw a line here. There he is. There's a starting. I put this on here and kind of drew out to 40, like that, and say this is 40 degrees. A lot of people go like that and say, what's the other piece that would fill this in here? What is the missing part to make a corner? So if you want to make 90 degrees, we say, what is its complement? Okay, we want, or complementary angles. So what goes with 40? Let's see, 90 take away 40. 50 degrees. The missing piece is 50. These two guys complement each other and they make a right angle, don't they? And how are you going to remember that? Well, here's what I remember. Giving compliments to people is the right thing to do, right? What's the right thing to do? Give somebody a compliment. There you go. And some people go like this. They say, hey, check out the word compliment, right? And then they just go like this. They go compliment. See the C? They go like this. What if I go like that and go, what is this right here? That sort of looks like 90. Okay. And what if, though, I took that same 40-degree angle and said, I would like you to go to make a straight line. Go all the way over here to make a straight line. What's the missing piece here? If you want to get to 180, we call this the supplement. Or that's S-U-P, not supper, but supplement or supplementary. And supplementary, in fact, if you look at any protractor, you see the 40? Oh, there's a glare on it right there. You see the number right next to it? These two numbers always add to 180. That 140 is if I went all the way the long way. In other words, somebody went 40, but what somebody came backwards? Or how far do I need to go to get all the way over here? And so let's see, 180, I already did 40. That leaves me with another 140 to go. So this piece is 140. We say these two angles are supplementary. They don't complement each other because they're not right for each other. Right? They're not right for each other. Look at that couple. They're so right for each other. They complement each other all the time. Aren't they a cute couple? Aren't they a cute couple? Remember, CO, like couple, right? Kind of like complementary. They're right for each other. But supplementary, well, if you can do sit-ups, and this is you, see, here you are. Whee, there you are, right? And you're doing sit-ups back and forth. You're really supple. That means you can really bend. Okay, so maybe remember that. Some people remember that C comes before S in the alphabet. So 90 comes before 180. Or remember my little trick? I did C, turned it into a 90. Some people take the word supplementary and they go like this. They go, what if you took this S and went like that? Then looks like an 8, and then go, oh, what if you turn the U like that and go, look, it says 180. Well, sort of, but yeah, so know those. So if they say, I have a 62-degree angle, and they say, give me a complement, you would go, what do I need? Oh, I need 90. So just go 90, take away 62. If you want to get 90 degrees, and you go, well, 90 take off 62. 28's the other piece. Those would be complementary. And of course, down here, they say 28. If you want the supplement, just subtract from 180. Because you go, okay, 180 plus, or subtract 62, 118. 62 and 118 are supplementary. Okay, so know those. Okay, and now we're going to get into something different. Remove this. Okay, so let me tell you about the homework so far. Determine each angle's in standard position. That means they start at 0. That means they start, whoops, I lost my paper. That means imagine you had a piece of graph paper. There you go. Imagine a piece of graph paper, and here's the x-axis, so that's where 0 is, okay? It all makes sense later. We all start here, and then we work our way up, okay? That's the positive direction. Okay, so they're saying, where would you end up if you were at 145 degrees? What quadrant would you be in? So you have to think, and like I say, if you're in class, I'll give you one of these yellow sheets, and you go, where's 145? And you kind of like 30, 45, 60, 90. Oh, I'd somewhere over here. And so this is quadrant 2. Start over here as quadrant 1, 1, 2, 3, 4. And so they want to say, what quadrant are you in? So you have to think of which place you went. And so I just named my quadrants. But be able to name it, I'll do the same thing on the quiz. So think about where you stop. But if they give you a negative angle, if they say something negative, like if they say negative 100 degrees, you're going to go, oh, wait, I'm going to go the other way, negative. And go, well, see, well, 90 would be a fourth. And like, oh, I'd be a little bit farther. I'd be over here, wouldn't I? There's negative 100, a little past 90. And so, like, so what were the quadrants? 1, 2, 3, 4. Ah, here's where we're at. We're in quadrant 3. Okay. Next one, they just want to know, as I said before, acute, right, straight, or obtuse. Okay. Try to draw these, just like how you always do. Start at 0. If it's positive, go up. If it's negative, go down, and try to see how far to go. Here it says find a positive angle less than 360. That's the same as these. So give me a positive number. So someone says 395, you're like, wait, what? Remember I said the trick for these? If you're like, find another angle that's the same. And if you get confused or lost, the trick is either add or subtract 360 again. This will always, whoops, I wrote in the book. This will always get you right to the right spot, okay? Add or subtract 360 from each one of these. So when I saw these, if it was a big number, I subtracted 360. Say if you spun around, you'd just be right here. Now, if I have a negative, well, that's too small. Let's add 360. I'm trying to get an answer between 0 and 360. So either add or subtract, whichever seems to be better. Then they're going to say, give me some complements, make them add up to 90. So I subtracted each one from 90. This will all be useful later. And wait, you're too big. Okay, you're over 90. Okay, you can't do it. And then make them add to 180. Once again, I subtracted from 180. Okay, it's going to get a little weirder. Move this now. So we've come up with this system of 360 degrees, right? Very, very, very popular. But it's not always the best system, but 360 is all the way around. Like, what about a clock? Here's a clock. A clock goes to just 55, 60, doesn't it? We could have made a system with 60 minutes, and that's used for things too. And some people said, why don't we divide the clock? Why don't we divide a circle just into 100? Wouldn't that have been simpler than 360? It never caught on of making a circle 100. See, here's 5%, 10%, 15%, 20%, 25%, 50%. Imagine if you said, what time is it? 7:50. And 7:50 would be 50% of an hour. But we don't do that, do we? We kind of just decided to do 60. So yeah, we were kind of weird too, weren't we? We did it in something called minutes. And then we wrote the minutes into seconds. And we'd base it all on the 60. Of course, isn't 360 kind of like 60? In fact, these kind of line up, don't they? Oh my God, they're the same things, aren't they? 360 is just 6 times as much as 60. And so this is a system called degrees, right? So if you use 360, we call that degrees, don't we? But if you broke a circle into 100 parts, they call this gradients. It never really caught on. But there's another system called radians. And math people, well, let's see, trigonometry people and calculus people really like radians. And what is radians? Radians is this funny system. And you saw it on my wheel. And instead of saying these are the numbers, these are the numbers, these ones with pi. And you go, well, why did they come up with those? Okay, so you're going to have to learn this new funny system called radians. And normally I would do like a proof and all that. And the most simple explanation is this. Here's a circle, right? And we'll get it in focus for you. So you got to get this idea down here. And remember the circumference, see the circumference, and circum means to go around. The circumference of a circle is 2 times pi times the radius. Okay, and so here's the radius, right? There's the radius. And what people discovered is that, well, if you knew the radius, or if you put these together, 2 times pi would have been pi times the diameter. You could have did that, but people started saying 2 pi r, even though pi times the diameter is easy. What people notice is that, well, if you took this length, right, whatever this length is, maybe I took like a little string or a measuring tape and measured it out and took that. And so normally I would take like a string or here we go, a little twisty, right? And then you take that length and you go here and you take that length and put it right here. And you see how far I went? And maybe I'm gonna go right there and stop. I'm gonna do whatever this is and do the same thing here and bend it. That is called 1 radian. And just to let you know, it's about 57 degrees, but it's an irrational number. You go, what's so great about that? Well, if I took that radius, right, and bent it like this, that's called a radian. And if I put another one, I'd go right here. Normally we do like a little lab. I get about right there, okay? And I do another one about here. So I've done 1, 2, 3. And to get all the way to 180 degrees, I need a little bit more, don't I? Hey, what's that number a little more than 3? In fact, it's about 3.14 of these little things. Oh, that's pi, isn't it? Yeah, and that's why you see this. So the system called radians is based on the radius. So when someone says something's 1 radian, they mean you went the distance of 1 radius. And if you went 2, then 3.14, we call that angle pi. So it's a little funny, right? That means you did 3.14 radiuses. If you only went half of pi, you did pi over 2, didn't you? Half of pi. If you went 60 degrees, how many 60s go into 180? Well, 60 goes into 180 3 times. So 60 degrees is a third of 180. That's why we call this pi over 3. You're a third the way to pi. At 45 and 30, like how many 30s go into 186? You're 1/6 of pi. So these are fractions of pi. And if you kept going a little bit more, a little bit more, a little bit more, you get 4, 5, 6, 6.28. In fact, to get all the way around, well, if that's pi is 180. If you got the 360, you'd have 2 pi. Oh, I get the rule. The circumference is 2 pi times the radius. So sometimes what we do is like, hey, let's make it easy and pretend the radius has a length of 1, and then we'll just ignore it. All the way around a circle is 2 pi. And so that's what you see here. All the way around a circle, and back to the beginning, where 0 is, this is, and doesn't say it here, but you should write in 2 pi. So 2 pi is all the way around a circle. And so I have this big wheel, and I don't know if this is coming up backwards or if it's in the right spot. See, there's 0. How many 30s go? See, 180. Well, if you want to use not the degrees, but they say, tell me what it is in radians, you're like, well, that's pi. So a lot of people memorize these. And it's like, what? Yeah, well, sort of. You can use the sheet if you forget, okay? So there's pi. How many 30s go into 180? 6. So you're 1/6 of pi. How many 45s go into 180? 4. In fact, look, 1, 2, 3, 4. That's 1/4 of pi. How many 60s? 60, 120, 180. That's 1/3 of pi. That's 2/3 of pi. And they're all the way. In fact, this is pi over 6. 1 pi over 6, 2 pi over 6, 3 pi over 6. What's 3 over 6? A half. 4 pi over 6 reduced. 5 pi over 6 pi. And we can keep going. 7 pi over 6. Skip the green. 8 pi over 6, but I reduced the fraction. 9 pi over 6, but I reduced the fraction. 10 pi over 6, but I reduced the fraction. 11 pi over 6, and once you get to 12, 12 pi over 6 is 2 pi. You're back to the beginning. So it's a system called radians. It's a little weird. And a lot of math people argue degrees, radians, degrees, radians. Like people go metric, no, English, feet and inches, no, centimeters and kilometers, or Fahrenheit, no, Celsius, gallons, no, liters. So it's the same thing. Degrees, no, radians. And everybody argues over it, right? What's the best system? I like degrees. The world tends to use degrees, but math people really like the radians. Okay, I'm not one of those math people in the radians. However, there's problems where we actually need to use the radians and makes your life easier. It was really popular before the calculator was invented. Okay, so let's go back. I'm going to show you some more tricks though. Okay, so a lot of people get really confused about the radian thing. So they try to define it, and you can read it. But like they're saying, whatever this radius is, if you went that's a radian. Okay, a little funny. So here's some of the stuff I've shown you. That's 2, there's 3. Okay, some of this stuff about arc length and stuff and the word problems, we're going to do the word problems tomorrow. But one of the things they're going to ask you often to do is to switch from one system to the other. Like convert these degrees to radians or backwards. Now, you can always look them up, right? Okay. And my sheet also has a little chart here. We can just look them up, but wait a minute. What about 10? What about 20? What about 25? They're not all here, are they? This just gives you like every 30 degrees, and 45 degrees. Okay, it gives you the popular ones. So here's the trick of how to convert. And the conversion unit is this one. Since pi is 180 degrees, okay, this is the radian system. This is the degree system. And it's important you put the little degree symbol, because if you don't, people assume you're doing radians. Radians doesn't have a little symbol like that. So since these are the same, if you put pi over 180 degrees, this is considered 1. And this is your conversion unit. So if someone gives you something like 2 pi over 3, this is radians. And here's the trick. And they say, change it to degrees. Okay, here's the conversion unit. I just gave it to you, and I lost the pen. This is your conversion unit. You're just going to times it by, well, see, since I want degrees, put degrees on top and pi on the bottom. Why? Because watch what happens. So this is how you convert. Whatever rating you get, use 180 over pi. Because watch, pi's cancel. Cool. Then you can actually maybe do some reducing, or if you don't want to. Often I'm too lazy to reduce. 2 times 180 is 360. 3 times, well, nothing there is 3. What's 360 over 3? I can use my calculator. 120 degrees. So 2 pi over 3 is 120. Of course, I knew that, didn't I? See, there it is. I could just cheated, right? Well, it's not really cheating. That's why I gave you the sheet. 2 pi over 3 is 120. But this will always work. But see, if you get a weird one, like pi over 15, like how many degrees is that? Once again, just go like this, 180 over pi. So this is what you want to use, okay? And it's like, where is it in the book? It's a little hard to understand in the book, but that's what this is here, okay? So I want degrees, okay? So put the degrees on top. Okay, what happens? Pi cancels, and 180 over 15. 180 over 15. Maybe I can reduce the fraction. If I have trouble, I could use a calculator and go, what's 180 divided by 15? Oh, it goes in perfectly. 12. 12 what? 12 miles, 12 feet, 12 degrees. Pi over 15, that's a little bit. That's only 12 degrees. Okay, what if you want to go backwards? What if I gave you 12 degrees? I gave you degrees and said, give me radians. And sometimes people just say rad for short. Okay, how do you go backwards? Same conversion unit. But if you want radians, put the pi on top and the 180 on the bottom, okay? And multiply. So if you want degrees, put degrees on top. If you want radians, put the radians or pi on top. So how do you do this? Okay, well, let's see. I got 12 times pi over 180. And now you have to be good at fractions. 12 goes in here once, 12 goes in there 15. So you get pi over 15. Okay, a little tricky. Let me give you a different one. How about that 120? And he said, okay, let's make him radians. Okay, pi over 180. And then you can go like, okay, 120 pi over 180. See, zeros reduce. What goes? 6 goes in here twice. 6 goes in there 3. 2/3 pi. See, it works. That's the one we had back here. Okay, so the book gives you some examples. Here's degrees, and they made radians. How they do that? They put the radians on top. And then they do the other way. They start some with radians and give to degrees. Some of you can actually figure out how to do it on the calculator. Now, I'm not going to show you how because I never really use it, but somewhere on these calculators, there's a way to convert. Like this says convert. And some people have a button that will switch degrees to radians, but I can't, everybody's calculator is different. Some people they have to go into like something here, or some people find a button that goes back and forth, you know? Okay, so I'll leave that up to you. If you can figure it out, sweet, right? But I usually don't use it because I get all messed up with it and then I do it backwards and then I get the wrong answer because I did it wrong. And then I pick up a different calculator and it's different and I don't know what I'm doing, okay? Okay, so that's where I stop today. They do show you the wheel in here. Tomorrow I'll tell you about the word problems and the arc length. So tomorrow, Tuesday, I'll tell you about these ones, okay, with that little formula. But you can do all these conversions. See, here's my degrees to radians, radians to degrees. Tomorrow I'll tell you these word problem things and what if they don't come at night. But we'll stop there for Monday and do what you can. And on Tuesday, we'll have another video to finish up 4.1. Remember, don't get behind. Okay, so hopefully the lesson makes sense. And when you get good at math, you'll be the coolest kid in school, right? All right, see you guys tomorrow.